Unit 1, Lesson 6, Part 2. Absolute value equation, special solution types, notes and examples. So you'll need to open up into your notes. You're going to be putting these in the notes. I'd have the teacher pause the video while you get your notes out. Okay, now in your notes, right, I can recognize when an absolute value equation has no solution, one solution, or two solutions. Now with this, there are 4 options that you'd end up with. If the absolute value of stuff equals a negative number, you will get no solution. I encourage the teacher to pause as we move through this to allow students to write it down. The second option, if the absolute value of stuff equals a 0, then it's one solution. If the absolute value of stuff equals positive, then you should end up with 2 solutions. And if the absolute value of stuff equals something with a variable in it, then you're going to have to solve and guess and check. The one with a variable in it might be something like 3x plus 5 in absolute value equals 4x minus 1. If you have one like this, you are just going to have to solve and check the solutions to figure it out. Because 4x minus 1, it could be negative, it could be positive, it could be 0. And it's going to change for different values of x. So in a situation like this, you just have to solve and then check to find out. If your absolute value equals a positive number like this, you are going to get 2 solutions. If your absolute value equals a 0, then you'll get 1 solution. And if it equals a negative number, you will get no solutions. So that's the basic idea there. Now, further in the notes here, we're going to look at several examples, and these can be replayed through, and this video will be available on Canvas because it'll be posted to YouTube and linked in Canvas, so you can view it again there. Consider this example. Absolute value 2x plus 11 equals 5. First thing you should notice is the absolute value is already by itself. We expect to get 2 solutions on this one because it equals a positive number. We go ahead and split it out into its 2 equations. 2x plus 11 equals 5. It also could equal negative 5. Let's start with the 2x plus 11 equals 5 and see where that leads us. If we subtract 11 from both sides, we get 2x equals negative 6. And then we're going to divide both sides by 2, and that gives us x equals negative 3, which should be a solution, but we're going to check it in a moment anyway. On the other one, we would subtract the 11 from both sides. Negative 5 minus 11 is negative 16, so 2x is negative 16. We'll go ahead and divide by 2, and we get x equals negative 8. Now, with these 2 solutions, we need to check them out back in the original problem. Remember, it was 2x plus 11 in absolute value. Here's 2 times negative 3 plus 11. And this is 2 times negative 8 plus 11. Well, 2 times negative 3 is negative 6. Negative 6 plus 11 is 5. This one works out just fine. This is negative 16 plus 11, which is negative 5, and absolute value is 5. Both of those work, so both of those are answers. X can be negative 8 or negative 3. Okay, next example. 3x, absolute value 3x minus x equals 4. Now first, recognize that this absolute value is not yet by itself. So we're going to have to get rid of the x from this side by adding it. We'll have to add it to both sides. Remember that when I do something on both sides, I put it in a red box to highlight what I'm doing. So this gets the absolute value by itself, and now we can split that absolute value. 3x could be 4 plus x, or 3x could be the opposite of 4 plus x, which is negative 4 minus x. We change the signs on both of them. Now starting with solving this, we're probably going to get rid of that x, so let's subtract x from both sides. This will give us 3x minus x is 2x. And x minus x is 0, so we just have the 4. Divide both sides by 2, and you get x equals 2 as a solution. On the other side, in the other equation, go ahead and add x to both sides to get rid of it. This gives you 4x equals negative 4. Divide both sides by 4, and we get x equals negative 1 as a solution. So let's try both of these out and see if it works. For 3 times 2 is 6. 6 minus 2 is 4. That one works. This is 3 minus negative 1. 3 plus 1 is 4. That one works. So these actually, even though there was a weird x on the other side, they ended up working out where we got both solutions. X can be -1 or 2. Okay, here's another example. Absolute value 5b plus 10 equals 5. We're going to need to get rid of that 10 first, so we need to subtract 10 from both sides. 10 minus 10 is 0, so that's gone. 5 minus 10 is -5. Now at this point, because it equals a negative number, it is not possible for you to get a solution. Absolute values cannot equal negatives, so once you get to that point, you would say no solution. You don't have to finish it all the way. Okay, next example. Absolute value of x plus 5 is 5. A lot of 5s here. We need to get rid of this plus 5, so we're going to do subtract 5 on both sides. The 5 minus 5 gives 0, so that's gone. And the 5 minus 5 gives 0, but I need the 0 as a placeholder here. Now, at the splitting part, because this equals 0, there is only going to be one solution. So because there's no negative 0, 0 is just 0. It's not positive, it's not negative. We're only going to get one solution when it equals 0. Right here, we subtract 5 from both sides, we get x equals -5, and that does check out just fine. And we just report the answer as x equals -5. Okay, next one. Okay, this one has an x on the other side, so we are not sure at this point how many solutions it will have. Absolute value x plus 3 equals 2x. Let's split that out into x plus 3 is 2x and x plus 3 is -2x. Okay, solving this one first, I think we ought to get this x and move it over there. Subtract x from both sides. This will give us 3 equals x, and that's actually done for now. We'll have to check it in a moment. Okay, on this side, we'll probably get rid of this x, subtract x from both sides. We get 3 equals -3x. We'll go ahead and divide by -3. And we get x is -1. Okay, when we try out this x equals 3, 3 plus 3 is 6, 2 times 3 is 6, it works. X equals 3 is the solution. When we try out the -1, -1 plus 3 is 2, absolute value 2. 2 times -1 is -2. 2 does not equal -2, so it's not one of the solutions. 3 is the only solution that works. So we didn't know at the beginning how many solutions there were going to be, because we don't know if this is positive, negative, or 0. But we found out that with it being 3, or 3 was the only one that worked, so there was only one solution. Okay, all right, this is kind of a complicated looking problem, and there's a lot of steps to it. It's not one that you need to be able to do at the 8th grade level, but I do want to demonstrate it because I think there's value in seeing this problem done. So applying what you know to something new. Absolute value of 3x plus 3 equals absolute value x plus 3. First thing I would do is reorder it so the absolute value x plus 3 is on the left side. We're used to seeing it there. And we're going to split based on that absolute value. So let's do the split. X plus 3 could be exactly what's on the other side. Absolute value of 3x plus 3. It also could be the opposite of it. So x plus 3 could be the opposite of the absolute value of 3x plus the opposite of 3, or just -3. So I've changed the signs here. Notice the absolute value, instead of being a positive number, if there's a negative in front of the absolute value, that forces it to be a negative number. Now let's go down this side. We're trying to get the absolute value by itself so we can split it again. So let's get rid of the plus 3. We're going to do -3 on both sides. And that gives us x equals 3x. And that's actually ready to split. Let's split the 3x. 3x could equal x, or 3x could equal the opposite of x. Okay. Go ahead and continue down with this. This is kind of an interesting looking thing. Let's subtract an x from both sides, and that'll give us 2x equals 0. If we divide by 2, we just get x equals 0. Great. On this one, if we add x to both sides, we get 4x equals 0. And we get the same answer, x equals 0. So the first two answers are x equals 0. And we'll check those down there in just a moment. Now on the other side, we need to do some work to get this absolute value by itself. Let's start by adding 3 to both sides. And that gives x plus 6 is the opposite of the absolute value of 3x. Then we need to change the signs. And that gives us Negative x minus 6, changing both of those signs, is the same as the absolute value of 3x. Now we can split it. 3x could be exactly what's there, negative x minus 6, or 3x could be the opposite of what's there, positive x plus 6. Okay, scrolling down, let's do this one first. Let's add x to both sides. Okay, that'll give us 4x equals negative 6. Divide both sides by 4, and we'll get x is negative 1.5. Okay, 3x equals x plus 6. Let's subtract x, and that'll give us 2x equals 6. Divide by 2, and we get x equals 3. So we have three different answers, 0, negative 1.5, and 3. Let's try 0 first. Original equation, absolute value 3x plus 3 equals absolute value x plus 3. Plugging in 0 here, we get 3 equals 0 plus 3. That actually works. There's nothing wrong there. If we try in negative 1.5, negative 1.5 plus 3 is 1.5, and 3 times 1.5 is 4.5. So 1.5 equals 4.5 plus 3. 1.5 does not equal 7.5, so that one doesn't work. Let's try 3. 3 plus 3 is 6. 3 times 3 is 9, plus 3 is another, that brings up to 12. 6 does not equal 12. So 3 didn't work, negative 1.5 didn't work, but 0 did. The only one that ends up working here as an answer is x equals 0. That is our only answer. Now, in your practice, number 1, you're going to solve each of these equations, report your answer as a solution set, and you need to check your solution. These are like the problems that we just did a bunch of in this video. Number 2, determine what values of A and B will make each statement true. So this is what we put in our notes today. What has to be A and B for this to have no solution? What about one solution and two solutions? I think you'll find that A doesn't really matter, but B does. And that's in your notes from today. Number 3, you get to solve an equation with some fractions in it. Number 4 is doing greatest common factor, and here's an example of it. 2x plus 4, greatest common factor is 2, so we factor out the 2. 2 times x plus 2. Now notice if I distribute this, I'll get back to where I started. 2 times x is 2x, and 2 times 2 is 4. And you're just doing the distributive property backwards, essentially, there. Number 5 is a solving problem. Just get x by itself. Number 6 is draw a triangle with an area of 10 square units. Number 7 is like the last one we did on the video. You might in fact, the 2x plus 2, I did the same thing in the video here, except those were 3's. So if you get stuck on that, you might consider rewatching the video by logging into Canvas at home and looking at that. Of course, you can ask a question about it on Monday as well. Number 8, in solving absolute value x plus absolute value x plus 1 plus absolute value x plus 2 equals 3, 8 equations are ultimately produced. That's because each absolute value splits into 2 equations. Anyway, 8 equations are ultimately produced, giving the solutions negative 6, negative 4, negative 2, 0, 2, 4, and 6. X equals 0 is produced as a solution twice. Determine the solution set for this by checking all the solution and eliminating extraneous solutions. So when you do the solving on this, which it takes pretty much a full sheet of paper to do this problem, and you wouldn't be expected to be able to do it as an 8th grader, but if you do solve through it, you get those 7 different solutions. Check them and see which ones actually work.